All right, geometry students, welcome to our first virtual lesson we have of this year, working through school with 2020. We've been lucky to be in school for so long, but now we got a couple of remote learning days. All right, so if you've been in my class before, you know I've made lesson videos before, so that's what I'm going to do. I'm going to teach you guys 4.2 this way. If you haven't been in my class before, then welcome to your first video lesson. All right, so here's what we have. We've been working with trig ratios. We did that in 4.1, and then we did that project yesterday. So we're going to expand on that. What I'm going to show you guys today is we're going to look at what inverse trig ratios are, and what those do is they help us figure out missing angles of a triangle. All right, and then what we're also going to do is expand on trig ratios, and I'm going to show you guys law of cosines, and we're going to use that to solve triangles. And when we see the phrase solving triangles, that basically means we're going to find out missing angles and sides of triangles. All right, so when someone says you're going to solve a triangle, that means you're just going to find missing angles and sides that exist in that triangle. All right, so let's first take a look at our inverse trig ratios and how that would work. Okay, so here's what we've done so far. If we know what the angle measure of a right triangle is, then in your calculator, we can figure out what the trig ratio would be. All right, like for example, like cosine 30, if we put that in our calculator and hit enter, we would roughly get 0.87. All right, so let's kind of get a visual of what that means. So cosine, your trig ratio for cosine, it's a fraction. Our acronym is CA. So it means on a triangle, we would have the adjacent side over top of the hypotenuse. And when you take those two numbers, when you have the adjacent side over top of the hypotenuse, all right, and you're at a 30-degree angle, you would get 0.87 when you divide that. All right, if we did a visual here of a triangle, okay, here would be our right triangle. Let's say this is 30 degrees. Okay, so you're located here at that 30-degree angle. This would be your hypotenuse, your adjacent side, and your opposite side. Okay, so really what it means, if you're at this 30-degree angle, the length of this side over top of this side, the adjacent over top of the hypotenuse, those two numbers would equal 0.87 when you divide them. Okay, so that's kind of what we've been doing with trigonometry. All right, we could also go the other way, which means we could do an inverse trig ratio. Okay, and what that means is if we know what the trig ratio would be, like if we know it would be 0.87, we can use our calculators to tell us what the angle size would be. All right, and in on your calculator, if you look at it, you'll see a button with this -1 there as an exponent. Okay, it doesn't mean we're actually going to do anything with that exponent. That's just means it's a math term for inverse. All right, so a -1 means we're doing the inverse. All right, so it's signaling that. Okay, so let's create a visual. Let's say we had a triangle. Okay, we got this triangle here. And you have your right angle. All right, and let's say you are at this angle here. And so you'd have your hypotenuse, your opposite, and your adjacent. Okay, and if you had numbers for these two, all right, like if you knew that your adjacent over top of your hypotenuse does equal 0.87, all right, if you knew that it would equal that, then what you could do is put that in your calculator and you could discover that this would be a 30-degree angle where you're located. All right, we'll put this into practice and it'll make some more sense, but there's kind of a visual of what we're doing. Let me show you guys how to use that in your calculator. So on your calculator, so let's say you knew that the sine ratio calculated to 0.85. So on a triangle, your sine ratio came out to 0.85. You can take that 0.85 and use your calculator to tell you what your angle size would be on that triangle. So if you were at this location and you got 0.85, your angle size is 58 degrees. Okay, and here's how you would do that. So on your calculator, you would hit the second function and you would hit sine, because if you look up above sine, you would have sine to the -1, then put in your number 0.85, hit enter, and you would get this right here in your calculator. All right. Try this one here for tangent. Okay, follow the same process. Let me erase these things here. Okay, so if you knew your tangent ratio was 0.71, we could do the inverse trig ratio, the inverse tangent ratio, and find our angle size, which would be 35 degrees. Okay, so to do that, just again, you'd hit the second, hit your tangent button, and then we would have 0.71, enter, and it should get you this right here. Tell you your angle size. All right. So let's use this on an actual triangle itself. Okay, so here we have this triangle, and we're trying to find out what is the measure of R. Okay, so angle R. So meaning you are right here at R, and you're trying to figure out what size that angle is. Okay, so we know we're located at R, so let's go around the triangle and label it just like we've been doing. So this would be your hypotenuse, this would be your opposite side, and this would be your adjacent side. Okay, and notice what you have. All right, you have two sides of the triangle that you know. You know the adjacent side and you know the hypotenuse. So what you want is the trig ratio that deals with the adjacent and the hypotenuse. All right, and that trig ratio, if you're thinking about it already, is cosine, because our acronym is CA. So we would have adjacent over top of hypotenuse. So that's the one we're going to use. Okay, so here's how we would set it up. We would say cosine R. All right, so cosine of angle R is equal to adjacent over top of hypotenuse. So 5 over top of 5.7. Okay, so we actually know what the numbers are. And so now we'll divide it and see what our trig ratio is going to come out to. Okay, so if you divide those two, round it to the 4 decimal places, you would get 0.8772. Okay, so that's what your trig ratio comes out to. All right, so now that we know what the trig ratio is, we can figure out this angle size, okay, because we're going to take the inverse cosine ratio of this. So in your calculator, we're going to go cosine -1 of 0.8772. And if I do that, it'll tell me what angle size angle R is. Okay, so if you work that out, it'll roughly come out to 29 degrees. Okay, so that's how we end up using it. All right, that gives us a better example of how we'd find the angle size there. All right. Okay, so let's take a look at this thing called law of cosines. All right, so we've been using trig ratios, and if I go back, trig ratios work if we have a right triangle. And it's a pretty useful tool because it lets us find missing angles and missing sides of a right triangle. Okay, and it only works for right triangles. It doesn't work for the other ones. All right, but what somebody did, who probably makes a lot more money than I do because they came up with this crazy stuff, all right, they figured out a way to partially use cosine and partially use, if you look at this looks like the Pythagorean theorem. So they came up with a way to use the find missing sides and missing angles of any triangle out there. All right, so they came up with some formulas that will work for finding the missing sides and angles of any triangle. Okay, and here's what we got. We got 3 of them listed here in standard form, and they look very bizarre. I admit that. All right. The ones in standard form are going to be used to find missing sides. Okay, and the ones in alternate form are going to be used to find missing angles. Okay, and we'll refer back to the screen as we go along. All right, so let's take a look at when they would be used. But first of all, take a look at how this triangle is labeled. So they got angles A, C, and B. All right, and it doesn't matter how you label your triangle. A, B, and C could be either angle on here, but what you want to make sure is side A needs to be straight across from angle A. Side C straight across from angle C, and side B straight across from angle B. Okay, so you need your sides, your lettering to be on opposite sides of your angles. Okay, so that's really important. Okay, so let's take a look at when we would use law of cosines. We can use it when we know a side angle side. Okay, so if we have information on a triangle and we have the side angle side, we can find a missing angle or side of this triangle, or we can use it when we know side, side, side. All right, we'll put it into an example and it'll make a whole lot more sense. Okay, so let's take a look at our first example of using cosines. Okay, so here we have this triangle here. It is obviously not a right triangle. Okay, and what we want to do is find the length of xz. Okay, so that's what we're trying to figure out, is what is the length of xz? So this down here. And if you notice, the information we have side angle side. Okay, because if you take a look, we have a side, we know this angle, and we have this side over here. All right, because of that, we can use law of cosines to find this missing side. The first thing we want to do is relabel the lettering on this triangle to match our example on the previous slides. Okay, so let's go back. All right, so we want A and little a, B and little b, C and little c. We want to label it just like this to help us make sense of our formula. Okay, so I'm going to go back. I don't need these letters. And I'm just going to label it just like they had it. All right, A and C and B. And then I want to make sure little a is straight across from big A, little b straight across from big B, and little c straight across from big C. Okay, so I relabeled my triangle. And now that I did that, I can find what formula I want to use. So I'm missing side C. Okay, so I'm going to go back to my formulas. And I have 3 different ones. This one here with C squared, this bottom one, will tell me the length of side C. So this is the one I want to use to figure it out. All right, so we'd have C squared equals A squared plus B squared minus 2 times A times B times cosine C, which looks like a whole crazy mess right now, but once we plug the numbers in there, it's really not too bad. So I'm going to take this formula and I'm going to copy it down onto the triangle I'm working on right now. Okay, so I'm going to take this and I'm going to go over to where we're at. And what I'm solving for is C squared is equal to A squared plus B squared minus 2 times A times B times cosine C. All right. Let me go back, make sure I got that right. Okay, looks good. Okay, so there's the formula we're working with. Now what we got to do is just plug in all of our numbers and we're going to do some calculating. All right, we don't know what C squared is, so we're going to leave it as C squared is equal to, now just start filling in all of our numbers. So my A is 30, so I have 30 squared, plus B, 35, so 35 squared, minus 2 times A, which is 30, times B, which is 35, times cosine C. All right, so times cosine, and for C, angle C, I have 110. All right, so all we did, we just took that big mess of a formula and we plugged in all of the numbers where they belong. All right, now that we got all the numbers, it is just a matter of going through and calculating, and I'm going to go through calculate these one step at a time for you so you can see what we get. Okay, so C squared is what we're trying to calculate. All right, this would get us 900 plus 35 squared is 1,225 minus 2 times 30 times 35 is going to get me 2,100. So these three numbers come out to 2,100, and I'm going to put times cosine 110. Okay? All right, so that's what I got so far, just doing this step by step. Okay, next I'm going to add these two numbers. So I have C squared is equal to 900 plus 1,225 is going to get us 2,125 minus, and then in my calculator, I'm going to go 2,100 times cosine 110. Okay, so do that in your calculator, and it's going to get you a negative answer. It's going to get us negative 718.24. Okay, so I'm just going to round it to 0.24. All right, so that's what we have so far. We're just calculating. So now I'm going to do the math with this here. So I get C squared is equal to, this would come out to 2,843.24. All right, and if I'm ever going too quick on this video, just pause it so you can catch up. Okay, so now we got it almost done. C squared is equal to this number here. Okay, but we're not quite finished because this, it represents C squared. So I want just plain C. So I need to take the square root of that number there. All right, so if I take the square root of that number, that's going to give us 53.3. All right, which would be our length of C. Okay, so that whole crazy mess of a formula ended up getting us that number right there, our length for C. All right, so pretty cool. It worked out. Okay, so let's take a look at another example. We found a missing side. Now let's take a look at a triangle where we're going to find a missing angle. All right, so take a look at this one here and look at the pieces of information that we have. All right, we have a side, side, side. Okay, so we know all three sides. So we can use law of cosines to help us find the missing angles. So they want us to find each one of these three missing angles. Okay, so first I'm just going to relabel my triangle using the A, B, and C from a few slides ago. So I'm going to cross out these letters and I'm just going to relabel it. And it doesn't matter which one is A, B, and C. So we could just say A, B, and C for each angle. And then the important thing, I want my sides to be across on the opposite side of my angle. So this is angle A, so I want this to be little a. This is angle B, little b. This is angle C, so I want that side to be little c. All right, that's the critical part. Okay, now I want to start finding what these missing angles are. Let's just start with A. Okay, so let's say we're going to find what size angle A is. Okay, so let's go back and look at our formulas. Okay, so the one I want to use, these ones deal with the angles, and notice how I have cosine A, cosine B, cosine C. I'm going to use cosine A because I'm trying to find what size angle A is. All right, so cosine A is going to be this formula here. All right, so let's take a look. We'll jot this formula down, and then we will plug in all of our numbers and work out the math for this one. All right, so let's take a look at what this would come out to. So cosine A, we got b squared plus c squared minus a squared. All right, so cosine of A is equal to b squared plus c squared minus a squared. All right, so that's what we have so far. And then let me double check what we would have underneath of it. Underneath, I'm going to have 2 times b times c. Okay, so let's go back. All right, underneath of here, I'm going to have 2 times b times c. Okay, now the formula looks like a big mess, but the good news is we have all the numbers that we need to be able to figure out what this is. Okay, so we are trying to solve for cosine A. So we're going to plug everything into this side over here. Okay, so we're going to say cosine A is equal to, now let's just plug in some numbers. We have 7 squared plus 13 squared minus 11 squared, all over top of 2 times b, which is 7, times c, which is 13. Okay, so we got everything filled in where it should go. All right, now it's just a matter of getting this calculated. All right, so cosine A is going to come out to, okay, 7 squared plus 13 squared is going to get us 218. All right, and then minus 121 for 11 squared, all over top of 2 times 7 times 13, which is going to get us 182. All right, just like that there. Okay, now we're just going to continue calculating this some more a little bit, one step at a time. All right, so we're going to have cosine of A be equal to 97 over top of 182. All right, and then we'll divide that, and it's going to get us a decimal number. All right, so 97 divided by 182 is going to get us, if we round it to the first 4 decimal places, we got 0.5330. All right, so 0.5330. All right, so what we just found out is our cosine ratio for angle A comes out to this decimal number here, 0.5330. So that's our cosine ratio. So we need to convert that cosine ratio into an angle size. So that's where we're going to use our inverse cosine button on our calculator. So what we're going to say is cosine -1, just meaning the inverse. All right, so our inverse cosine of 0.5330. Okay, if we put that into our calculator using our inverse button there, that's going to get us what our angle size is. All right, so if I do that right quick here, we got 0.5330. We're going to end up with 58. Rounded. All right, 58 degrees. All right, so that tells us what angle A is going to be. It's going to come out to 58 degrees. Okay, so kind of crazy. We put in all those numbers, we did some calculating, and it ended up being 58 degrees. All right, so we got one of the angles. Okay, we got 2 more to find. All right, now before you groan too much, we got to find, we're going to use the same process for one of the other angles, and then we'll shortcut it and we'll be able to figure out what the last one is. Okay, so let's go to angle B and we'll calculate what that is going to turn into. All right, so I definitely ran out of room on this slide, so I'm going to go to my next slide here, not this one. This one right here, okay, because I already know that that's 58. So now I'm going to go to angle B and I'm going to get that calculated. Okay, so angle B, we're going to go back and take a look at our formulas. It's going to be almost identical to what we just did, except for we're going to be using this formula here, the one that involves cosine B. Okay, so we got a squared plus c squared minus b squared over top of 2 times a times c. Okay, so let's get that jotted down. All right, so we'll go to where we're at. Okay, here we go. So we're finding cosine of angle B. Okay, and that's going to be equal to a squared plus c squared minus b squared over top of 2 times a times c. All right, and let me make sure I got that right. Okay, I'll get you guys that formula back in a second. Okay, so there we go. 2 times a times c, a and plus c minus b squared. Okay, perfect. There we go. We got a and b squared minus a and c squared minus b squared over top of 2 times a times c. Okay, so we got it. It's a long formula, so it's good to check it out to make sure you got it written down correctly. Okay, so let's fill in some numbers, do some calculating. Cosine of b is going to equal, now just fill in your numbers. You have 11 squared plus, for c, we have 13 squared minus b is 47 squared. All right, all over top of 2 times a, which is 11, times c, which is 13. Okay, so we got all their numbers in where they go. Now it's just a matter of doing some calculating. Okay, so cosine of b is going to equal, okay, so we have 11 squared plus 13 squared will get us 290 at the end. All right, minus 49 all over top of 2 times 11 times 13 is going to get us 286. Okay, so we got that so far. All right, so now what we're going to do is take 290 minus 41 or 49, and that'll get us 241. Okay, so let's jot this down. We have cosine B is equal to 241 over top of 286. All right, we got a fraction. Now we're just going to divide it to see what that comes out to. All right, and we end up with, let's see, the first 4 decimal places, we got 0.8340. 0.8340. Okay, so what that decimal number represents, this is what our cosine ratio for B comes out to be. All right, so now we just need to switch this ratio into a angle size. So we're going to use our inverse cosine on our calculator. So cosine, the inverse, so put that -1 there, of 0.8340. And then we'll just calculate what that comes out to be. All right, and that'll tell us our angle size, which is going to come out to, let's see, cosine 0.8340 is going to get us 33 degrees kind of roughly. So we're rounding. So we got 33 degrees. All right, and that would get us that size there. Okay, so now we know that angle B is 33 degrees. All right, now we just got to find angle C. Okay, and we don't have to go through this whole long process again, because what do all 3 angles of a triangle have to add up to? All right, I hope you were thinking 180 degrees because that's correct. All right, so this one will be a lot simpler to find. We can just add together 58 and 33 and see what that comes out to. Okay, so if we do that off to the side, we would take 58 plus 33. All right, and that's going to get us 91. All right, then we just got to take 180. And we're going to subtract 91 from that, and we're going to end up with 89. All right, so that would be our missing angle size there. So we didn't have to repeat that whole long process again. We could just jump right to that and calculate that as 89. All right? Okay, I hope you guys are with me so far on this, and it's not too bad. I got one for you guys to try. Okay, so try this one out to see what you can come up with. You're trying to find the length of DE. All right, so what you want to do is first go through and relabel this triangle ABC however you want to, and make sure you label your sides, and then figure out what formula you're going to use to get that calculated. All right, I'll give you a few minutes, and then we'll take a look and see what you guys came up with. Oh, so you can go ahead and pause the video. Okay, let's see what you guys got for this. All right, so let's check out our setup here. All right, so first I'm going to go around and relabel what our different sides are. So what I did is I called this one A, and this one up here is B, and this one down here was C. So I relabeled the angles. Now I want my sides straight across from there to be matched up with my angles. So I got little a, little c, and way down here is little b. All right, and I'm trying to find the length of little b. All right, so the length of DE. Okay, so I use the formula that deals with b squared. Okay, so here's the formula I've used for finding the missing side. I don't know what b is, but I know what everything else is. All right, so then I just plugged in all the numbers for everything else. All right, I got A, I got C, and here I have A and B. Okay, so now that we got that, or this should be C, A and C, they got that wrong. Okay, A and C. All right. So now we got all those numbers in there. Now it's just calculating. This would come out to 580. 2 times 18 times 16 times cosine 21 gets us 537.74. So then we just subtract them, and we would get 42.26, but that's b squared. So you got to do one last step. You got to square root that, and your b comes out to 6.5. All right, so that would be your answer for B. So take a look at that math, see what happened there. If you missed a step or somehow didn't get that calculation, recheck it and see what you got. And if that worked out, let me get you guys your assignment here for today. Okay, so you guys are working on assignment 4.2 worksheet. I got that posted in Google Classroom for you. So get the whole thing done, and you can either turn that in through Google Classroom, or you can wait to turn it in when you guys come back to class. All right, so I hope to see you guys again soon. And if you got some questions, we can go over this stuff. Let me know. I can either answer through email, or I can help you out through Zoom, or I can help you out when you guys come back to class. All right, thanks for watching. I'll see you guys next video when we're going to do 5-3.